Principles on Bioproduct Separation, Module 14, Ancillary Operations, Segment 3, Waste Disposal. With me, Yusuf from School of Life Sciences and Technology, Institute Teknologi Bandung. Previously, we have discussed about water quality and solvent recovery. In this segment, we will discuss about waste disposal. Fermentation produces two types of residual materials in major amounts that must be discarded. These are the residual biomass and the spent liquid streams. Each presents its own special disposal problem. The residual biomass can be recovered by methods discussed in Module 2 and 3. It is then often partially dried. In some cases, this byproduct has commercial value, for example as animal feed. In many cases, these materials have been used as landfill. Recent concerns for odors and possible contamination of surrounding groundwaters have inhibited this method of disposal. Incineration of the biomass remains a possibility, but the presence of inorganic and corrosive salts can foul the incinerator. As a result, many waste streams are discharged to conventional sewage treatment plants. This often works well but does require caution. Any fermentation medium is a complex mixture of nutrients needed for microbial growth. These mixtures include both soluble and insoluble substrates at relatively high concentrations. Their utilization is at best only partial. As a result, these waste streams have high biological oxygen demand. Fermentation waste have a high biological oxygen demand that they should not be added directly into a municipal system without dilution or independent treatment. Certain microorganisms in the waste must be rendered non-viable prior to discharge to prevent the spread of pathogenic and toxic substances. Conventional oxidation processes used for both fermentation waste and domestic sewage are shown in the figure. The two processes differ in the method of oxidation. For figure in the left, oxidation is by means of a trickling filter, a packed bed of rocks covered by moss over which waste is trickled countercurrently to a flow of air. For figure in the right, oxidation occurs when air is forced through a suspension of activated sludge. During the oxidation process with the activated sludge, additional sludge is produced. As a result, the concentration of suspended solids can become so high that the sludge is difficult to pump. Both methods can result in 70 to 80% reduction of biological oxygen demand. Except for the method of oxidation, both processes are similar. Both begin with the primary treatment, which removes suspended solids. Both follow with a secondary oxidation. The resulting effluent is usually discharged into a suitable river or stream, where further dilution gives relatively clear water. The operation of both plants must be monitored to detect upsets and to ensure satisfactory oxidation. For the next segment, we will discuss about biosafety. Until then, I am Yusuf from Institute Teknologi Bandung.